Hello, dear learners. When you are attending a maths lesson with me, get ready with a book, pen, and your calculator. In the last class, we discussed arrangements of letters or digits when repetition is allowed or not allowed, and also learned to use the factorial notation. Today, we are going to see arrangements with the restrictions. Let's see one example. In how many different ways can the letters in the word compare be arranged? So all what you have to know about this is how many letters are there in the word compare. So how many letters are there? There are 7 letters in the word. So we are going to arrange them in any order without any restrictions. But if the question is not talking about the repetitions, that means repetition is not allowed. Even though it is not mentioned in the question, repetition is not allowed because the question is not talking about anything about repetition. Then repetition is not allowed. So let's go to A, without restrictions. So all these questions that we are doing with arrangement of letters or digits, make sure that you start by looking at the positions of arrangement. So here we have to arrange 7 letters. So there are 7 positions to consider. Let's look at the first position. Without any restrictions, how many choices do we have for the first position? Because there are 7 letters, we have all the 7 choices. We can start with C, O, M, P, A, R, or E. All the 7 choices. But for position 2, now we are only left with the 6 choices. Position 3, 5. Then 4, 3, 2, 1. This is the situation here. So when it is starting from 7 and ending at 1, what do we call it? That is called the answer. You can directly, you don't need to write that 7 times, 6 times, 5 times, 4 times, 3 times, 2 times 1 anymore, because you learned factorial notation. You can directly write that the answer is 7 factorial. Now you just use your calculator for finding 7 factorial. 7 factorial is equal to 5040. So the answer here for A is 5040. Okay. Now we are going to see the second question. In B, in how many different ways can the letters of the word compare be arranged beginning with 2 consonants? Okay. So here you must also know what are consonants and vowels. What are consonants in this word? In this word, consonants are, okay, let us write the consonants here. The consonants here are C, M, P, and R. So there are 4 letters that are consonants. How many vowels are there? O, A, and E. So that's how the total number of letters are 7. So out of the 7, 4 are consonants and 3 are vowels. Now we have to arrange beginning with 2 consonants. So let's look. So here these two first 2 letters must be consonants, the restriction. So the remaining we have no restriction. It can be any of the vowels or consonants. So but the first 2 must be consonants. So how many consonants are here for the first position? There are 4 consonants available. How many consonants are available for the second position? Because we used one consonant here, only 3 consonants are remaining. I hope that is clear. Now the next position, there is no restriction there, so you can use any of the 7 letters, but 2 letters are already used. So how many letters are remaining? 5 letters only remaining. Now that means this one now 4, this is 3, 2 and 1. So when you write the answer, you can just write the product as it is, or you can also write 4 times 3 times 5 factorial. Because starting from 5, third position, it's factorial now. So using the calculator, you can find what is the answer now. The answer is 1440. Okay, number C. In how many different ways can the letters of the word compare be arranged, beginning with exactly 2 consonants? That is, the first 2 letters are consonants and the third letter is not a consonant. That's what they meant by exactly 2 consonants. So this one is 2 consonants. The third letter should not be a consonant. That is what the question is saying. Okay, we already know if it should be a consonant, we have 4 choices to make there. So that means here we have only 3 choices. Here it should not be a consonant. So how many choices do we have? If it should not be a consonant, that means it should be a vowel now. So any one of the 3 vowels can come here. But here there are no restrictions. So any of the 7 letters can come here, but we already used 3 in the first 3 positions. So how many letters are remaining out of 7? 3 are used, so 4 letters are remaining. So from here, when there are no restrictions, that's when the factorial starts. So it's 4, then 3, then 2 and 1. So when we write the answer for number C, we write 4 times 3 times 3. These were the restrictions. Now, without any restriction, the remaining 4, which is 4 factorial. That's how we write the answer. Now, if you have any questions, please comment. So, using the calculator, 4 times 3 times 3 times 4 factorial, it's 864. So, the final answer for number 3 is 864. Okay. Now, D. How many different ways can the letters in the word compare be arranged? If the alternating consonants and vowels. Okay. So now the letters must be alternating consonants and vowels. That means here now we are going to have a okay, let me write what is happening when alternating consonant and vowels. That means we can have a consonant here, a vowel here, consonant and a vowel, consonant and a vowel, and a consonant. And this is only choices too. This is only way for arranging. Because if you start with a vowel, in this case, if you start with a vowel, it's vowel, consonant, vowel, consonant, vowel, consonant. Then you don't have another vowel remaining. It will still a consonant because we have 4 consonants and 3 vowels. The number of consonants and vowels are not the same. So this arrangement is not possible. We cannot start with a vowel when it says alternating consonants and vowels. So only this arrangement is possible in this case. So we start with the consonant, then vowel, consonant, vowel, consonant and vowel. Okay, let's go to consonant first. How many consonants are available for the first position? We have 4 consonants. Let's look at the consonant position again now. Let us fill in all the consonant positions. How many consonants are now available? We used already 1, so 3 are remaining, 2 and the last one. Let's go to the vowel positions. How many vowels are available here? 3. All the 3 are available for the first position. Then comes 2, then comes 1. So actually this answer here you can quickly write as because when you wrote all the consonant only, it's actually 4 factorial. When you write the vowels, it's 3 times 2 times 1, which is 3 factorial. Only one way of arranging, so that's only possibility. So the answer is 4 factorial times 3 factorial. I hope you also have your calculator with you, so you must also check what is the answer. The answer is 144. Okay, now E. If M is not the first letter, how do we do that? Okay, M is not the first. That means here in the first position, you cannot have M. That is what it says. So that is a restriction in that last part. Okay, if M is not possible, how many letters are still available? Out of the 7, M is not possible. That means all the other 6 letters are possible. Okay, now from here, do you have any restrictions? No. So here you already used 1 here in the for the first position, any other letter except M, but that means all other letters are available for the remaining. All other 6 letters, whatever we used here is gone. All the remaining 6 letters are available for the remaining 6 positions like this. So when there is no restrictions, it's factorial. So here the answer for E is 6 times 6 factorial. So the answer is 6 times 6 factorial. It's 4320. That is answer 4320. Okay, I hope you understand this one. Can we also do the groupings now, because we only did one question today? Let's also see groupings now. So what we were doing just now was arrangements with the restrictions. They are very important. They always ask in the examination. Now groupings. In groupings, let's see this example. So I have written something here which is also important for what we did just now, that you must always remember that restriction should be addressed first. Okay, now look at the groupings now. A family consisting of 5 people, 2 adults and 3 children are going to a movie. In how many ways can they sit in 5 adjacent seats under the following conditions? So the first condition here is the parents must sit together. So here the groupings. Grouping is parents, the father and mother must sit together. So that is a grouping. So whenever you see groupings in a question, what is happening is you're going to make that group, you are going to consider the group as 1. That is what is happening. That means here we have the parents, father and mother, must be together means they are now going to be considered as a pack, and we count it as one. Actually, how many people are there in the family? In the family, we have a five people. All together, there are five people, two adults and three children. So it's like this: father, mother, then three children. This is the family. So now, in the first condition, first question, they are saying the parents must sit together. So that means the father and mother is now going to be considered as a pack. So we count it as one, remaining three children. So this is now we are going to count as one. So this is now 2, 3, 4. We count this now as 4 people now, only because of the grouping. So 4 people can sit in how many ways? In there 4 people can sit in 4 factorial ways. That is what we saw in the previous example also. If there are 4 things, how do we position them? Any one of the 4 can sit here, then any remaining 3, any one of the 3 can sit here, any one of the 2, like that. So if there are 4, it's 4 factorial ways. Okay, so the answer for A now is going to be 4 factorial, but we are not going to leave the group now. The group is this now, father and mother. So because there are 2 people, they can also sit in 2 different ways, because father can sit first or the mother can sit first. So if you only consider the group alone, there are 2 positions. So first position, any one of the 2 can sit, second position like this. So this grouping itself, inside the group, they can sit in 2 factorial ways. So the final answer will be 4 factorial times 2 factorial, which is 4 factorial times 2 factorial is going to be 48. So here the answer is 48. So if the parents must sit together, they can still sit in 48 ways. Okay. Now B. The children must sit together. So now the grouping is different. The children must sit together. So if the children must sit together, that means the children is going to be the new pack. So here now the pack is going to be the children. So we are going to say children, 3 children in 1 pack. And we call it as 1. How many? 2 adults are still remain. The father and the mother is still remaining. So there are 1, 2, 3. We are considering them as 3 people now. How many ways 3 people can be seated? 3 people can be seated in 3 factorial ways. We saw here how 4 people are seated. So in the same way, 3 people are seated in 3 factorial ways. Now we consider the grouping. Group of 3 children. How can these 3 children can be seated now? There are 3 people, so they can, this one can sit first or this one. So now these 3 people can always be seated in 3 factorial ways. So the final answer is 3 factorial times 3 factorial, which is 36. Okay, now we are going to see. The children must sit together and the adults must sit together. So here now we are going to have 2 packs. Children must sit together and the adults must also sit together. So all the groupings are considered to be packs. 1, 2. We count them as 2 people now. How can 2 people be seated? We know 2 can be seated in 2 factorial ways. Now we consider the packs. Okay, in the first pack we have 3 children. How many ways can they sit? How can 3 people be seated? In 3 factorial ways. Now we consider the second pack for father and mother. How many ways can they be seated? There are 2 people, so they can be seated in 2 factorial ways. So this is the final answer. When you put this in the calculator, you are going to get 48. Okay, now we are going to D. The father must not sit in the middle. The father must not sit in the middle. That means now we have a restriction. The father must not sit in the middle. Okay, let's see the positions now first. Now we have to go back to the position to see how we deal with this one. So there are only 5 people. The father should not be here. So I told you restriction should be addressed first. So let's see that first. So if father should not sit here, how many choices do we have for this position? It can be any of the 3 children or the mother. So how many people are there can be positioned here? 4. So now we look at the other one. Now other positions have no restrictions. So here any of the remaining 4, one of them have already seated here, including the father. Now we are left, one has already occupied this position. So remaining there are 4 people in the family. Any of the 4 can come here, remaining 3 here, remaining 2, 1. So here the answer is the 4 in the middle, any of the 4 in the middle times 4 factorial. So the answer will be 96. That's how we deal with the last question. So this is the most important part in this problem, that you deal with the restrictions first. Restrictions should be addressed first. Okay, I hope you enjoyed the lesson. If you have any questions that you want to ask, please write your comments in the comment box. Thank you for watching.